over the individual. In the world of ants, there are no individual heroes. Every ant is part of something larger. They willingly sacrifice personal gain for the survival. Part 1. The origin of ants, when the world belonged to dinosaurs. Around 140 million years ago, when Earth still trembled under the footsteps of giant dinosaurs, something almost invisible was quietly emerging beneath the surface of the planet's history, the earliest ancestors of ants. At the very beginning, ants were not social creatures. Their ancient ancestors evolved from a group of primitive insects similar to early wasps. These creatures lived solitary lives, hunted alone, and relied solely on individual strength to survive in a harsh and competitive world. The most compelling evidence comes from ant fossils preserved in amber. By studying these ancient remains, scientists discovered that early ants had longer and harder bodies than modern ants, large, powerful jaws designed for direct hunting, almost no signs of social behavior. In other words, early ants were simply small insects struggling to survive, day by day, in a dangerous prehistoric environment. However, nature never stands still. As flowering plants began to spread rapidly across the planet, Earth's ecosystems changed dramatically. Food sources became richer, but competition became fiercer. In this shifting world, some ants began to display unusual behaviors. Instead of fighting constantly, they tolerated one another, stayed closer together, and gradually learned to coexist. This subtle change marked the first spark of social life, a tiny evolutionary step that would eventually transform ants into one of the most successful organisms on Earth over the next hundreds of millions of years.
After a long period of solitary existence, ants entered the most critical turning point in their evolutionary history, learning how to live together. This was not a sudden decision, but the result of millions of years of trial, error, and natural selection. As environments became more complex, solitary ants faced constant threats, larger predators, unstable food sources, and harsh climates. In this challenging world, individuals that tolerated the presence of others had a better chance of survival. At first, cooperation was very simple, sharing the same shelter, avoiding unnecessary conflict, temporarily sharing food resources. Yet these small behaviors opened the door to a completely new path. Early ant groups gradually realized a powerful truth. Living together saved energy and increased survival chances. Over time, roles began to differentiate. Some individuals specialized in reproduction, while others focused on foraging, nest building, and defense. This marked the birth of a true insect society, rare in nature, but extraordinarily efficient. Remarkably, ants achieved this without a central leader. Their coordination relies on pheromones, invisible chemical signals. One scent marks a food trail, another signals danger, others help ants recognize nest mates. Through this simple yet precise communication system, thousands of ants can act as a single, unified organism. Each tiny individual becomes part of a collective intelligence, where the survival of the group outweighs individual instincts. This silent social revolution transformed ants from ordinary insects into one of the most successful life forms on Earth. Part 3. Collective Intelligence, when thousands of tiny brains become one great mind. If you observe a single ant, you may find it unimpressive. It is tiny, fragile, and has an extremely simple brain. An individual ant cannot plan far ahead, understand strategy, or lead others. Yet something extraordinary happens when thousands of ants come together. At that moment, the colony is no longer a group of separate individuals. It becomes a superorganism, a living system in which each ant functions like a cell. The colony behaves like a complete organism. Ant intelligence does not reside in individual brains, but in the connections between them. When an ant discovers food, it does not give commands. Instead, it leaves behind a pheromone trail. Other ants passing by will detect the scent, follow the trail, reinforce it with their own chemical signals. Paths leading to richer food sources accumulate stronger pheromone signals, and the colony naturally selects the most efficient route, often the shortest one. No planning, no maps, yet the solution is remarkably effective. This phenomenon has amazed scientists for decades. Ants solve complex problems using very simple rules. Thanks to collective intelligence, ants build extraordinarily complex nests, multi-level tunnel systems, chambers for larvae, food storage rooms, natural ventilation shafts that regulate temperature. All of this is achieved without blueprints or architects. Each ant follows instinct and chemical cues, yet together they create a system that operates with astonishing precision. Some ant species go even further, farming fungi as a primary food source, herding aphids for their sweet honeydew, protecting their livestock as fiercely as their own nest. Behaviors once thought to be uniquely human were mastered by ants tens of millions of years earlier. Part 3 reveals a profound truth of nature. Intelligence does not always require a large brain. Sometimes, it emerges from perfect cooperation among very small beings.
Part 4. Evolutionary Explosion. When ants conquered the planet. After mastering social organization and collective intelligence, ants entered the most spectacular phase of their evolutionary journey, an explosion in numbers, species diversity, and global distribution. This was the moment when ants stopped merely surviving and began quietly dominating the Earth, a golden opportunity after the age of dinosaurs. When dinosaurs went extinct, ecosystems across the planet were thrown into chaos. For ants, however, this disruption became a golden opportunity thanks to their small body size, rapid adaptability, flexible social structures. Ants quickly filled ecological gaps left behind by larger animals. Their expansion was both swift and relentless. The rise of extraordinary diversity. From a single evolutionary lineage, ants diversified into tens of thousands of species, each perfectly tuned to its environment. Desert ants endure extreme heat. Rainforest ants thrive in high humidity. Cold region ants survive short active seasons. Urban ants adapt to life alongside humans. Today, ants inhabit every continent except Antarctica, an achievement few organisms can match, masters of survival in the human world. As humans built cities, cleared forests, and altered climates, many species disappeared. Ants, however, did not retreat. They adapted. Some species learned to nest inside walls and foundations, exploit human food, waste travel across continents through global trade routes. Certain invasive ant species have even reshaped local ecosystems, demonstrating just how powerful their expansion can be. The biological weight of ants, one astonishing fact stands out. If all the ants on Earth were combined, their total biomass could rival or even exceed that of humans. This means that despite their tiny size, ants, as a collective, represent one of the planet's greatest biological forces. Part 4 makes one thing clear. Ants do not need size to conquer the world. They succeed through adaptation, cooperation, and relentless expansion. If ants were to disappear one day, Earth would not collapse overnight. But over time, ecosystems would begin to unravel. Because ants are not merely background creatures. They are silent workers that keep the natural world functioning. Every day, millions of ants dig, tunnel, and transport soil, creating vast underground networks. Through this activity, soil becomes better aerated, water penetrates more evenly, beneficial microorganisms thrive. In many regions, soils inhabited by ants are richer and more fertile, supporting healthier plant growth. Without machines or technology, ants have been performing this service for tens of millions of years. Few people realize that ants are among the most important seed dispersers in nature. Many plants produce seeds with nutrient-rich attachments that attract ants. Ants carry these seeds back to their nests, consume the nutritious parts, and discard the seeds in protected, organic-rich environments. As a result, seeds germinate more successfully, young plants face fewer predators, forests regenerate naturally. Without wings or speed, ants quietly plant forests one seed at a time. Ants are highly effective predators in the insect world. They hunt agricultural pests, consume dead organisms, keep many species in ecological balance. By doing so, ants help prevent destructive population explosions. They serve as a natural control system that humans struggle to replicate. Dead leaves, insects, and organic debris are all collected and broken down by ants. This process returns nutrients to the soil, reduces biological waste, sustains the cycle of life. No spotlight, no recognition. Yet without ants, nature would become slower, heavier, and far less balanced. Ants do not live only for themselves. They are quietly sustaining life on Earth. After hundreds of millions of years of evolution, ants have not built monuments like pyramids, nor written history in words. Yet their quiet persistence has become one of nature's most powerful lessons. Strength is not about size. A single ant can be crushed in an instant, but an ant colony is remarkably resilient. Nature teaches us a simple truth. True strength does not come from how big you are, but from how well you are connected. Ants survive not because they overpower others, but because they stand together. Persistence is the secret of longevity. Ants do not rush. They move in small, repetitive steps, day after day. No noise, no display, yet they never stop. This persistence allows ants to survive mass extinction events, adapt to extreme climates, coexist with humans across all eras. The collective over the individual. In the world of ants, there are no individual heroes. Every ant is part of something larger. They willingly sacrifice personal gain for the survival of the colony because they understand one essential rule. The individual survives only if the community survives. This principle has kept ant societies stable for tens of millions of years. A mirror for humanity. By observing ants, humans are invited to reflect. Do we cooperate as effectively as we could? Do we truly listen to one another as ants respond to pheromone signals? Do we prioritize collective well-being over short-term personal gain? Ants do not teach us to be small. They teach us humility, connection, and endurance. Final thoughts. Ants remind us that you do not need to be great to create value. With persistence, cooperation, and shared purpose, even the smallest beings can change the world.